Okay, let's talk about the 5 major processes that are going on with conditioning. And these are processes that were discovered initially by Pavlov, but have been researched for many years afterwards and continues to be studied in looking at various phenomena. Acquisition, extinction, spontaneous recovery, generalization, and discrimination. By the way, these 5 processes occur with both classical conditioning and operant conditioning. So let's explain it with classical conditioning. Acquisition, let's talk about that. Acquisition is the initial stage. This is where the association begins to take place. This is where the animal makes the association between the conditioned stimulus and the unconditioned stimulus. So the neutral stimulus becomes paired with the unconditioned stimulus. The organism makes that connection. That's the acquisition. That's that aha moment when that connection is made. Okay? In most cases, the neutral stimulus needs to come before the unconditioned stimulus. Think about Pavlov's case with the dogs. What would happen if Pavlov, instead of ringing the bell before giving the food, rang the bell after giving the food? Well, the dog is already salivating in response to the food. So ringing the bell is not likely to, the dog is not likely to necessarily learn to salivate just in response to the bell. I mean, it could happen, but it would take a lot longer for that process to happen. And Pavlov also studied the timing. So when was the ideal time to present the neutral stimulus to condition the animal to it? And basically the half second would be the ideal time. So about you ring the bell and present the food, like a half second in between. That would be the ideal time gap in terms of being able to quickly make this acquisition. You can make the acquisition in with a lot more time than a half a second, but the half second is something where you can make a fast connection. Second process we want to talk about is extinction. Just because you have learned to respond to a conditioned stimulus doesn't mean you are always going to respond in exactly the same intensity. What happens is your conditioned response can become weaker over time, and it becomes weaker when the conditioned stimulus is presented without the unconditioned. So let's go back to Pavlov's dogs for a moment. Pavlov rang the bell but did not present the food, and he did this over and over and over and over again. The dog would eventually stop salivating, and that's exactly what he discovered. Remember, the conditioned stimulus, which is the dog is salivating in response to the bell, and that was the conditioned response to the bell. But that conditioned response is going to disappear if the food never comes. So the food has to come after the conditioned stimulus in order to maintain that automatic conditioned response. So let's take a look at what Pavlov discovered. When the unconditioned stimulus does not follow the conditioned stimulus, salivation begins to decrease and eventually causes extinction. So as you can see here in the first half of the graph, this is the process of acquisition, where the association is being made, the pairing of the conditioned stimulus and the unconditioned stimulus. Once the unconditioned stimulus is taken away and now it's just ringing the bell, well, the dog will still salivate for a while, but it will gradually begin to decline, and eventually no more salivation in response to the bell. So that's extinction. Now, does extinction mean that the classically conditioned learned response is wiped off of the face of the earth, is completely gone? The answer to that is no. That response can return, and it returns through a process called spontaneous recovery. The conditioned response recurs after a time delay and without any additional learning. So, if you think about what's happening here, the animal has acquired the connection between the conditioned stimulus, the bell, and the unconditioned stimulus, the food. Makes the connection, the animal has learned it. Well, now you drop the unconditioned stimulus, you drop the food, you no more food. Well, eventually the conditioned response of salivating is going to disappear. That's extinction. But what happens if Dog's taken away for a while, taken away for a few hours, let's say. Then is brought back to the lab in the same circumstance, in the same setup. Then Pavlov rings the bell. Well, that response is going to come back, maybe at a lower intensity, so the dog is going to salivate just a little bit once that bell rings. And again, that's an indication of spontaneous recovery. So if you look at this chart here, the acquisition and then the extinction here, just like we saw before. But then there is a time delay. Then the conditioned stimulus is presented, the bell is rung, the dog starts salivating again. Again, not at the high point here, but it starts salivating. And again, the salivation will eventually decay. The process of renewal deals with, essentially, if you were to learn that, learn the classical conditioned response, but then that response is extinguished. Now you go to a different environment, a different building, a different place, and you might respond to that conditioned stimulus right away again, even after you have already had that response extinguished, because you're in a different context, and perhaps you might react different. You might say, you learn to react in one context, but maybe in a new context, you might start it again, even after it's been extinguished in the original context. Generalization is also an important aspect of classical conditioning. Basically, we are not always going to be hearing and seeing the same signals in the environment, but we need to nevertheless be able to react to those signals. Not all police sirens sound the same, but we nevertheless react to hearing it, and it's a good thing that we do. We need to be able to react to a police car that's coming out behind us. We have to get out of the way, or pull over, of course, if we've been speeding. But basically, when we hear new stimuli that are similar to the original conditioned stimulus, that might also elicit the conditioned response. So let's go back to Pavlov's dogs. What happens if he rings a bell of a slightly different tone, a different sounding bell? Now the dog might ignore that different sounding bell, but that's unlikely. The dog will most likely generalize. The dog will most likely salivate in response to this different sounding bell. It might not salivate quite as much as with the original one, but it will still salivate, and that's an example of generalization. And again, generalization. There are many examples of generalization. We respond with fear to different kinds of fear-inducing stimuli. We learn to react to different kinds of movies and whatnot. We learn to react to different kinds of stimuli, and essentially that shows how we can deal with a complex world around us, the process of generalization. All right? We recognize that different things can cause us pleasure, different things can cause us happiness, and we kind of learn to react to them. Here's an example of stimulus generalization that Pavlov studied. He wanted to associate a little vibration, a little vibrator that is attached to the dog, and clicking that vibration would presumably lead to the dog salivating. The idea being, he put the vibrator on its thigh, let's say. Now, when it vibrates on the thigh, then it gives the food. So, in other words, vibration on the thigh, feed the dog. Vibration on the thigh, feed the dog. So, essentially, the dog is learning to associate the vibration on its thigh with the food. Well, now what if Pavlov played around with this and moved it away from the thigh? Maybe now gave a vibrator to the hind paw, one to the pelvis, or one to the trunk, and did it with each of these and tested the dog's salivation. And what he found was, the further the vibration was away from the thigh, the less the dog salivated. This is an example of generalization. The dog is learning to respond similarly to similar stimuli. And the less and less similar that stimulus is, the less likely you are going to have the conditioned response. So that's an important thing to remember, is that when the stimuli are similar between the conditioned stimulus that you've already learned and and some other similar stimulus, if they're very, very similar to each other, then we're going to react in a similar way. If they are very, very different, we're going to react in less similar ways, or we might not even react to the different stimulus at all. And this is where we're getting into discrimination. We need to be able to tell the difference between two stimuli. Some stimuli that may be very similar, but maybe one is dangerous and one is not. I forget how it works. There's the king snake and the coral snake. They're very similar looking snakes, but it has to do with the pattern of the striping. The pattern of the striping is different for the king snake and the coral snake. The king snake is harmless. The coral snake is poisonous. So, if you're walking through the woods and you see a coral you see a snake that looks like could be a coral or could be a king snake, you might run away in fear because you've made the association between the colors of the snake and the and the poison, the fact that it can bite you and kill you. But you might be an experienced naturalist, and you might be able to tell the distinction in the two types of snakes. And the king snake, is harmless, so you might be skilled enough to see that it is a king snake, and you're going to be able to discriminate. So you might have an initial startle reaction, but upon a closer look, you're going to say this snake is harmless, and your conditioned response will not occur in response to the king snake, well, it would to the coral snake. So, with discrimination, you are learning to distinguish between the conditioned stimulus and a stimulus that is irrelevant. You might have two stimuli that are very similar to each other, and one, again, just like with the snake, one is dangerous, one is not. Likewise, you could have stimuli that are very different from each other, so we would normally not react to the one that's very, very different. But, the more different the stimuli are, the more likely we are to not react to this particular incorrect stimulus. The king snake doesn't bite. If you're exposed to the king snake day in and day out, and the king snake isn't going to bite, or it doesn't cause you to get a serious sickness, serious poisoning, well then you're gonna be comfortable with the king snake, and you're not going to react to it. While the coral snake, you will react with fear. So an advantage of being able to use both generalization and discrimination is that you're able to kind of distinguish, let's say, classes of stimuli that might lead to lead to a particular kind of reaction you might react to it, positive or negative. You might also have a class of stimuli that you say you're not going to be, you're not going to react to it. And if you can kind of distinguish those, you're able to kind of navigate the world around you. Here is an example of stimulus discrimination. The dog salivates in response to one kind of tone from the tuning fork because it's been associated with the food. The other sound, 392 cycles per second, well, no salivation here, again indicating that the frequency or the pitch of the tuning fork makes a difference. The dog learns when this tuning fork rings, I get food. When this tuning fork rings, I get nothing. So the dog learns no salivation in response to this one. This is discrimination.